So I was recently asked about plugin script, why I use ProcessBlock and not ProcessSample, and in this video I want to give you an example for why you might decide for one or the other. I have this baseline here that I made in Vital, and Vital has this cool option where you can put a stereo offset to the modulator that is then modulating stuff, and I put it on 100% so that it's really 100% offset to each other. And why? Because this is a bass sound, that might not be a good idea. But I like it because it adds a nice rhythmical movement. So what I want to do now is I want to saturate only the mids. And for this purpose, instead of just slapping a saturation plugin on it that does that, which I already did a bit, I will just program my own, because it will bring the point across really nicely. So yeah, let's start. So as always, I start by just making a new script into a new folder. Let's go. So my default script is this. And now, first of all, let's just sketch out what we want to accomplish. Mid-side, encoding, and then saturation only on mid, and then mid-side, decoding. And we want to accomplish this with ProcessBlock, VS, ProcessSample, and then we want to discuss the pros and cons of both approaches. First of all, let's get rid of this little method here. I don't need it. Yeah, we comment out ProcessBlock. We don't need it now. And now we can make parameters. Actually, we just need one parameter, which is drive. And let drive go from 1 to 8. I don't think we will need more than that, because as you know, when we use the classical 10H wave shaper and we have a parameter P in it, actually, yeah, let us also do this. Now P is a parameter that can, as I said, go from 1 to 8. And our transfer function would look like this. Yeah, so when we drive it harder, we decrease the volume, but we also make it go more drastical. And actually, we can go softer on the volume. No, that makes no sense. Yeah, well, anyway, if we did not do that, then it would be more obvious what we want to do. We just do this. Okay, maybe we just do this then. And if you want to look at this more like a signal, then you can still just exchange X with sin X, and then it would look like this. Yeah, so we saturate the signal, right? So we make a lot of overtones with that. So it's a saturation plugin. And yeah, 1 to 8 on drive. Now ProcessSample. Oops. Void ProcessSample takes in a double IO sample, and now I can loop through the outputs, audio outputs, and then just apply the saturation to it, which is, let's make a dedicated saturation method. float saturate, and we put in a, or actually that plugin script uses double for almost everything, so let's use double. So we put in a sample, and we also put in a parameter, a drive parameter, and and we output 10h of drive times sample. And I don't know yet if we will also divide by drive after that. Maybe getting too loud else. Yeah, at least we can add a little out gain for reducing it manually. But I don't want to use decibels now because that's like too complicated. Okay, so we actually have a little bit more to do. We also have output gain. So this is what we want to do. Now yeah, this is our saturation step. Now we also need the mid-side conversion. But yeah, how would I do that when I just have IO sample? Or is this really IO sample? I think it's array IO sample. Yeah, because it gives me both channels. Okay, good. So ms encode. Oh, what am I doing here? Oh yeah, that's a method, right? So we give it the IO sample, and then we say mid is IO sample 0 plus IO sample 1 times 0.5. That's the formula for mid. Mixing left and right channel, then going back, and side, which is the same but with a minus. And while we are at it, we can also write the function for decode. Oh, actually we forgot something here. We also have to replace IO sample, obviously. Now ms decode is almost the same, but we can let this stuff out and we rename these things so that it is actually readable code that makes sense, but fundamentally the same thing. Now we can encode and decode stuff. So what we do to test this is we run IO sample through both of these methods, and if it still sounds the same afterwards, then we probably succeeded. And we did not succeed. 41, no drive. 41. Oh right, because I called it D. Great, we succeeded. Now let us add the saturation step. In order to do that, we put this for loop here and say IO sample at channel equals saturate of IO sample of channel and the parameter. And we want to be more descriptive about the parameter, so we rather put it here so it looks better when we use the parameter. Now we can drive the signal, and while we're at it, we will also add the step for the volume. But I will not make a dedicated gain function because that would be kind of silly. Gain. And gain is input parameters 1. You know, 0 and 1. And yeah, that should work. Where is it? Let's check in a stereoscope if it works. If it does work, then the mid signal should be more belonging a little bit more now. Holy shit, it's really hard to tell, actually. Let us turn up this thing massively and see if this does not kill us. Okay, so not sure if the encoder and decoder work, but I just realized I can also put the gain here so that it's not too convoluted in the method. Doesn't matter. Same output. Now, what was my issue? I was sample 0 and 1 and 0 minus 1, left, right. Left, right. It should be correct. It probably is correct, but I'm just misunderstanding what I was even able to achieve, maybe. Another thing how we could try if it really works is by just saying that the side channel should be turned off by going this. Now it should be clear, hopefully. Great, and now I will also test if I can just remove the mid channel, and that's true. So it really works. It just gives different results as I thought, but I mean, that's the fun of making music, right? So this is the solution for ProcessSample. And then you might ask, yeah, if this is a perfectly doable plugin idea in with just using ProcessSample, then why would I use ProcessBlock instead? And the reason for that becomes only clear when you know how the information is laid out in memory. Usually, actually, not sure if it is implemented like this in plugin script, because that would kind of make it impossible to get an array of these, or maybe it uses one or the other depending on which method was defined or something like that, since you can only use one of them. I don't know, but usually, and for example also in the Juice framework, so if you ever plan to use different frameworks, then you will often find that the way the samples are laid out in memory is dark mode. And now let's say this is the content of one channel, this is the content of the next channel, so like left and right, and then there are the samples in it, you know, these are supposed to be slots, like this is slot 1, slot 2, and so on, of the individual channels. Now what happens when you use something like ProcessSample? It means that for each sample, like 1, you will have to do something with this thing, and then something with this thing, and then you go forward 1 sample, and then you do something with this and something with this, and that's just a pattern that goes on and on. While when you have ProcessBlock, you can decide to actually process something in a way that is called block processing, where you only process one channel. You do this, then you do this, then you do this, then you do this, and only when you have reached the end of the left channel, you actually start to do something with the next channel. Actually this first, yeah. And so on. And only when you have reached the end of that, then your processing has finished. And that can give you a performance boost. And I would say this does not matter too much in plugin script, but if you want to invest more into your DSP career, then I hope that it makes sense, that I actually care about that. And according to everyone, that really makes sense. Because, you know, VST plugins are very performance, they are applications or plugins that rely a lot on performance. Yeah, that's a nicer way to say it. So how would we rewrite this in ProcessBlock? We would do it in the following way. So just like in ProcessSample, we would start by getting our parameters. Now you can already see the first difference. Rather than just getting the parameter values for each sample, you only get them for each block, which makes a lot of sense because memory access, like from getting stuff from an array like here, is more costly than access from variables. And also you don't notice the difference between block processed parameter access or sample based parameter access anyway, so it is totally fine to only pull them once a block. And you can sometimes gain a little bit of performance just by doing that, especially if you have further calculations with these parameters, which is often the case. Imagine I had a decibels gain parameter now, so one that does not go from 0 to 1, but something like minus 60 decibels to 0. That would mean, without really doing that now because I don't have the formula in my head, if I had done that, then I would have to convert the resulting value to so that it can be used in the code, and it would happen either for each sample or for each block. So in this case, for each block would make more sense because it's cheaper on the CPU. Now, next up, we want to do the encoding and decoding steps. This is still a little bit problematic because, as you can see, in order to encode a sample, you need to have both channels. So this is indeed something that requires some sort of sample-based processing, I guess. Yeah, so maybe when it comes to that, I don't know, maybe there are different solutions that I just don't think of right now, but they probably look really weird, so I will not do that. So we will just do the same as we did. We will encode the signal for each sample. Of course, now it's not called IO sample anymore, but it's called data samples of no channel, just data samples. Or actually, no, that makes no sense, because what data samples is giving us is a two-dimensional array. So we need a new formula for encoding. MS-encode, another MS-encode for arrays of doubles. Now block processing, right? So now that we have this, and we also have this, we have the number of samples, we can go through all the samples, and for each sample we replace a bunch of stuff. But this time it's not IO sample, but it is samples, because that's what our argument is called, of channel 0 and sample S, and plus sample of channel 1 of sample S, and same for these, and also here. Yeah, that looks about right. Now same for MS decode. Alright, I just realized there is no data samples to process here. We have to use this argument. And now, decode. Of course, we call them left and right instead of mid and side. And just as before, the only difference is we take away the multiplication at the end. Now that should do the trick. So now we can MS encode data samples and also samples to process. And at the end of whatever we do now, we use the decode step. Now that already looks pretty neat, in my opinion. There is no saturation in it yet, but let's just add it now. Data samples channel sample gleich saturate also data samples, but with our parameter drive times gain. Actually, we don't even need these because it's a one-liner. Easy peasy. Now let's go and check out if it works. Probably not. Oh, it does. Cool, and it instantly works. I have made no mistake. Let's go back with this value. It makes no sense to go so high. Actually, it makes sense to go a little higher, maybe. Oh, I just noticed a big mistake that I made. You might probably have asked you already, why would I saturate both channels if I only want to enhance the mid channel? That is the reason why the stereo image did not go smaller. So instead of actually using the channel at all, I just assume that we only want to use the first channel because it's the mid channel due to the mid-side encode step. And now finally we get the results that we want. We don't? Why not? Why not? Why not? What happens if we use the side channel? Yeah, that really, okay, at least for this example, I could hear that it actually goes more to the side. But this one should have actually have a little bit more of an effect, in my opinion. What happens if we go harder? Yeah, I mean, honestly, the effect just has a hard time to get any mid signal out of it because the processing that I did in Vital was just really hard, and one should really not do that with the base patch, I guess. So it really did its best job to combat that a little bit, and you can clearly hear, at least with these very high values, that it adds some midiness or something like that. So let's go back to the actual topic. Now I have to actually change the process sample as well. Now instead of even having a channel loop at all here, we only have IO sample 0. So these would be the equivalents. And yeah, that's basically it. You can use ProcessBlock and it will probably take a little bit longer, and you have some little benefits in that, like that you can do some calculations only once per block and save a bit of CPU. And you also have some disadvantages, like that some things can actually not really be done in the sequence of channels first and then samples, while you have the advantage that other things can be done that way and will be very happy to be used that way as well. Yeah, so ProcessSample on ProcessBlock. I would say it is good to just generally forget about ProcessSample, because the benefits of ProcessBlock in the long run, if you make bigger plugins than a little test script that doesn't even have 100 lines, are very obvious. You will run into many cases where it makes sense to have used ProcessBlock. So if you started using ProcessSample in a project and then quickly run into the issue that you want to go to ProcessBlock instead, then you will notice at some point that you could just skip that step and just generally use ProcessBlock without even thinking about it, because you will run into this problem anyway. And then yeah, and then you will just do the things that have to be done. Sometimes there are even things that cannot even be done with channel static. Like once when I wanted to make a randomized LFO, and the problem was that I first had to get a signal for, how can I describe it in an easy way? The randomizer needed to pick a new random value, but when a new random value was picked, it also needed to change its frequency a little bit. So it had randomization on amplitude and frequency. And if block processing was a thing, then that would imply that you can just draw the phase that says when a new random value has to be picked before doing the gain changes based on this new random value appearing. But that makes no sense, because the random value also changes the frequency. I don't know if that made sense now, because it's like really far-fetched from this code here, but that was just an example of what can happen if you try really hard to make everything block processing. So sometimes it just doesn't work, but it often works, and it's often more nice. And yeah, that's my opinion about ProcessBlock vs ProcessSample. I hope that I didn't forget anything important, but yeah.